line? What do we always need to figure out?
The slope?
Yes.
Okay.
They say the other line, not this line, but the other line they're talking about is parallel. What is the other line's slope?
The other line slope?
The line that's parallel to this line. The fact that it's parallel means it has the same slope.
Okay.
What is its slope?
Would it be 12 and negative 5?
What's the slope of this line?
Oh, 3/4?
Negative 3/4.
Oh, okay.
The coefficient, in other words, when you have y equal mx plus b, the slope is m, the y-intercept is b.
Okay.
Okay? So, we know the slope. And we know a point that the line goes through. Well, there's a perfect thing for that. It's called point-slope format.
Okay.
Have you had it? Because most people get taught two things. They get taught y equal mx plus b, one format, and I don't need to use the easier point-slope. I could actually do it using that, figure out the equation of the line. Let's do it both ways.
Okay.
Let's do it this way. If I'm going to use this, well, what do I know? I know the slope, so I know this much of it. But I don't know b. If I knew b, I would fill it in, and that would be the equation of the line. Can I figure out what b is? This line that I'm talking about goes through that point. What does that mean? That means when x is 12, y is minus 5. So
okay.
I'm going to plug in the y value is minus 5. I'm going to plug in the x value is 12. And notice that now I can solve for b.
Okay.
Minus 5 equals minus 9 plus b. b equals positive 4. Now I go back up into this equation, and now I know b. So I know everything I need to know. Your final equation's always going to have an x and a y in it. The only reason I filled in for x and y was so that I could calculate b. But once I calculate b, here's the equation of that line. Notice it is different. It's not the same as that. Okay? Now, as long as we talked about it, what's the format for point slope? That's the other common format. Whether you have it or not, you don't necessarily need to do it or to know it. As long as you know this method here, you're fine. You can always use this method.
Okay.
But point slope is this. And I can solve it immediately because it's called point slope for a reason. You only need the slope and you need a point. Well, my point is that. So my y sub 1 is minus 5. My slope, I knew, is minus 3/4. And my x sub 1 is 12. There's my equation in one step. Done.
Okay.
So using point slope is actually quicker than having to go through this and solve for b. Notice that this was 1, 2, 3 steps. This was one step. But in order to use this, you do have to remember that, and you have to know what y sub 1 and x sub 1 are the coordinates of your point.
Okay.
And if you have 2 points, you can use either one of them. So use either method that you like. Only because in the question he doesn't say, give me the answer in y equal mx slope-intercept format. That's what y equal mx plus b is called, is slope-intercept, because you have a slope and you have the intercept.
Yeah.
Over here it's called point-slope because we have the slope and we have the point. Okay. They both incidentally give you the same equation. This equation right here that we got, if I continue to manipulate this, will end up being the same thing. It'll be minus 3/4 x plus 4. But this is a perfectly good answer all by itself without doing anything more to it. Maybe turning this into plus 5, but I don't have to distribute and move the 5 over or anything. Not if they don't ask for it in a certain format, and they didn't here. Okay, if angle A and angle B are complementary, what does that mean?
Isn't complementary when they equal 90 degrees?
Yes.
Okay.
Supplementary is 180, complementary is 90.
Okay.
So, what equation can I write?
4x plus 31 minus -2.
Plus, you just said they add to 90 degrees.
Okay.
Well, it's plus angle B.
Okay.
And I can use parentheses just for clarification here. So, yeah, it's plus this. Okay, all of that's equal to 90. Now, when I go to remove the parentheses, this turns into minus 2x plus 43. So when I remove the parentheses, when I have plus minus together, it becomes minus. And now you just need to do what? It's the next step to solve. They want to know the larger angle. So
yeah. So
we're going to solve for x.
Yeah, combine like terms next.
So we have 2x plus 74 equals 90. What now?
Subtract 74 from itself in 90.
Okay. What now?
Divide 2 from itself in 16.
So x equals 8. So angle A is what?
Angle A is 4 times 8 plus 63.
Which is the larger angle? Do we need to figure out what angle B is? Not if they're complementary, we don't.
Okay. Oh yeah, because they both equal 90 degrees.
Right, so the angle B has to be 27, but we don't even need, once this came out to be greater than 45 degrees, we knew it was the larger angle.
Okay.
And so we're kind of done. In other words, you would not want to spend time plugging in 8 here to figure out what this angle is. All that effort would be just kind of wasted. And I would imagine that time is going to be a factor, is it not, on your test?
Yeah, we got 90 minutes to do all this, but it's sometimes not enough, so.
Yeah, by a factor, I mean it's definitely something you need to pay attention to. How can I solve this third? What equation?
I'm not really sure. I tried doing this one earlier because we had time in class, but I couldn't really figure it out, so.
What's true about angle 1 and 2?
They're. What are the terms? They're not the same, but they're.
A linear pair.
Yeah, thank you.
What does that mean? What does that mean? The fact that they're a linear pair, what does that tell me?
that they add up to 180.
Okay. So, and what's the relationship between 1 and 3?
They are complementary.
No, they're equal. They're vertical angles.
Okay.
Okay, in other words, whenever you have two lines cross, that angle is equal to that angle, and this angle is equal to this angle. Always. As long as they're straight lines.
Okay.
Okay? And that's all I did here, was I crossed two lines. Okay? So, if I set this equal to that, does that allow me to solve for anything? In other words, 1 is equal to 3, but that doesn't help immediately.
Yeah.
Because I have one equation, but I have two variables.
Mm-hmm.
So, that's not the first thing I can do. That doesn't accomplish anything. But what can I do in order to solve for x? I need an equation that only has one variable.
So you can take the 16x minus 18 and equal it to 10x?
Is it equal to this angle? What was the relationship between these two angles?
They're a linear pair.
They're supplementary.
Okay.
That's all. So all linear pairs are supplementary. But the key here is they add to 180. So let's add them and let them equal 180.
Okay.
Now that's an equation I can solve because there's only one variable in it.
Mm-hmm.
Once I solve this for x, now I can set this angle equal to that angle, and that will be a number. It will no longer have a variable in it.
Okay.
Okay. Let's go ahead and do it. Let's solve for x. Gather like terms. What do we got?
26x, and then negative 15.
Okay, now 26x equals 195. Surely that's a round number. No, it isn't.
7.5.
Oh, that's not bad. 7.5. Really? It's exactly 7.5?
That's what my calculator's giving me, so.
Okay. So, that's okay. There's nothing that said we can't have fractions. So, now that tells me what this angle is, right?
Yeah.
It's 16 times 7.5 minus 18. Now, what's that going to be equal to? Those are vertical angles. Vertical angles are equal.
Okay, so 16 times 7.5 minus 18.
Equals what?
102.
Okay, so 102 equals what?
12y?
Yeah, they're vertical angles, so they're equal to one another. And now you can solve for y.
Okay, it would be 8.5.
Okay, so x is 7.5, y is 8.5. Now, this is a very typical problem. And its only difficulty is if you try to start out by equating that to this.
Okay.
It doesn't let you solve it. Always know that you can only solve an equation if you have as many equations as you have variables.
Okay.
What do we know about this thing right here? What is it called?
The line running through it?
Yeah. Well, okay, that's one way to put it, yeah. It's called mid-segment also.
Okay.
Same name as the mid-segment of a trapezoid. But what it basically means is that it bisects each side. It bisects this side so that that's equal to that, and it bisects this side so that that's equal to that. And furthermore, that makes that line parallel to this line.
Okay.
By definition. In other words, if that's a midsegment bisecting both sides, then it is parallel to the base of that triangle. That's the base. Okay? Now, if that's parallel to that, what is the relationship between this triangle and the big triangle? Let me draw them out.
Okay.
In other words, I like to do this because it's a little easier to see if they're separated. This is 5y plus 1. This is 66 degrees. This is 34 degrees. This is 23. This is 34 degrees. What's this angle right here?
That's 34.
Are these triangles similar?
Yes, so wouldn't that be 66 too?
Right. But first
Okay.
of all, why are the triangles similar? What do you need to show similarity?
They have the line.
They have to have three angles that are all the same.
Yeah.
Okay, well, the only one we know for sure is the same as that one. That's 34 in this triangle, and it's the same angle for the big triangle. So that's 34 there. But here's the thing. When I said this line is parallel to that line, well, now you have two parallel lines, and that's a transversal, right?
Okay.
What happens when you have parallel lines and transversals? It makes that angle equal to that angle.
Okay.
Can you see where I'm pointing?
Yes.
Okay, now that we have that angle is 66, and we know that this angle has to be 66, now we know the two triangles are similar, but we didn't know it before then. If this line is not parallel to that line, then those two triangles are not similar.
Okay.
We have to know that this line is parallel to that line, because they don't label it that way. The only reason we know that is because this line bisects both sides of the triangles. That makes it a mid-segment line. That makes it parallel. The fact that it's parallel makes that angle the same as that angle. Now we have a similarity. Well, we know two angles of this little triangle here. The only thing they want us to solve for is x. So what is 4x plus 4 going to be equal to?
Or, that would have to be equal to, would it be 180?
No, the sum of the angles of a triangle add to 180.
Okay.
That's only one of the three angles. What are the other two add to?
The other two.
Yeah, what does this one and this one add to?
100?
Okay, so what's that make this one here?
80 degrees.
So my equation is what? 4x plus 4 equals what?
Equals 100?
No, 4x plus 4 equals 80. That angle.
Oh, okay.
That's why we solved for it, so that we can write an equation and solve for x. Well, I know that that angle has to be equal to 80 degrees based on the measurement of the other two angles. So I can set 4x plus 4 equals 80, which makes 4x equal 76, which makes x equal 19. Now, what is the similarity ratio between these two triangles? They don't give it to you, but you can figure it out. In other words, I know that this side is twice this side, correct?
Okay.
I mean, do you see why? That side has a single hash mark through it. That hash mark means this side is the same as that, which means this whole side has to be twice this side.
Okay.
So if that were 10, this would be 20. If that were x, that would be 2x. But it's important to know the similarity ratio. The bigger triangle, every side on the bigger triangle is twice the measurement of the corresponding side on the smaller triangle. Well, they tell us that on the smaller triangle, this side is 23. So what does this side have to be?
That one's 23. They have to be twice what 23 is?
Correct, which is?
46.
Okay, now what equation can I write to solve for y? Because we go back and look at the question, we have to solve for x and y. We didn't. The question was not solve for that side, but solve for y.
So, would it be 5y plus 1 equals 46?
Correct. Y equals 9. I didn't really mean to use x here because they're using x as part of the measurement of that angle, so I should have used another letter here, r,
Yeah.
r. The important thing is to understand that the big triangle is twice, I don't even want to say twice the size, because that connotates area.
Yeah.
Every side of the big triangle is twice as long as its corresponding side on the small triangle. If this side was 5, this side has to be 10. If this side was 7, this side has to be 14. That's what similarity ratio means. It means the same thing as your R sub L. It means the same thing as a linear ratio.
Okay.
Okay. Notice that the linear ratio here is 2, right?
Yeah.
What's the area ratio? It's the relationship between linear ratio and area ratio.
Okay.
What is it? The area ratio is what relative to the linear ratio? The square.
Yeah.
Whatever the linear ratio is squared. So the area ratio is 4.
Okay, so
if I said this triangle is 4 times bigger than that triangle, I'm referring to the area.
Okay.
Okay, the area of the triangle is 4 times bigger than this triangle because the linear ratio is 2. We know it's 2, but that's why I use words like similarity ratio, not this triangle is twice as big as this triangle, because it isn't. It's actually 4 times as big. But each side is only twice as big.
Okay.
Now, this line is also called what?
The mid-segment.
Mid-segment. Same properties as this line. It bisects both sides. It bisects this side and it bisects this side. That makes it parallel to this line.
Okay.
And it also makes it halfway between this and this.
Okay.
In other words, whatever the length of that base is, let's say that's 10, and this base is 14. Well, this base is 12. Okay? So, what equation can I write? In other words, again, I want to solve for x. How do I, let me do another problem real quick. if this side is 10 and this side is 14, and I want this mid-segment line that bisects the sides here, how would I get it? What is x going to be? It's the average.
Yeah. So
What's the average between 10 and 14?
12.
How'd you get it? I mean, because it's halfway in between, right?
Yeah.
What it really is if you add the little base to the big base and divide by 2, you get 24 divided by 2. That's how you really get 12.
Okay.
So I can say that the mid-segment is equal to the top base plus the bottom base divided by 2. Right?
Okay.
So translate that to an equation for our picture. I know the mid-segment is equal to the top base plus the bottom base divided by 2. So what's my equation?
So top base. Okay.
Start with 28. What's 28 equal to? Spell it out. I don't want you to solve for x immediately. I want you to give me the equation.
Okay.
In other words, all geometry comes down to is writing the equations and then solving.
Yeah.
Okay? So I want to make sure you can write the equations. So what is 28 equal to? How did we do it when we had 10 and 12 or 10 and 14?
Yeah.
We added them and divided by 2. So add the top base to the bottom base and divide by 2. What do you get?
So if you take the top base and...
Yeah, spell it out for me. There's the top base.
Yeah. Okay, so it'll be 20.
No, just spell it out for me. Don't do the math. Just spell it out. Top base plus the bottom base. What's the bottom base?
2x plus minus 8.
And you got to divide all of that by 2. So there's your equation. That's the equation I wanted you to come up with. If you can come up with the equation, I'm not concerned about you being able to solve this. I hope you can solve that, right?
Yeah.
Okay. You should be able to solve that rather easily. But coming up with the equation is the tough part. Is all we did was followed our words. We said the mid-segment is equal to the top base plus the bottom base divided by 2. That's all I did.
Yeah.
No magic. Just if you know the words, then you can fill in what you have for the bases. And notice that I have an equation with only one variable, x. Solve this for me.
Okay, so...
What's the first step?
Wouldn't you combine like terms for the first step? So...
No, I like to get rid of denominators. I hate fractions.
Okay.
So why don't we multiply both sides by 2?
Okay,
that's going to make it a lot prettier looking. And by that I mean make it look a lot easier to solve. Now, I don't need that set of parentheses, and I don't really need that set of parentheses because they're being added, not subtracted. In other words, if that was a negative sign, then I would need this set of parentheses because that negative sign would have to be distributed to both of these terms. But since that's a plus sign, I don't need the parentheses. I can write it exactly like this.
Okay.
Now what?
So you would combine my terms, so 3x minus 1. Okay, and then...
Now add 1 to both sides and divide by 3. That solves for x. And in terms of whether you start this by combining the numerator or multiplying by 2, in this case it doesn't matter.
Okay.
In other words, had I done your step first, this is what I would have. And now I would multiply both sides by 2. Or I would combine all of this and then I would multiply by 2. But at some point I'm going to multiply by 2. So I just find it easier to get rid of my denominators as quickly as I can.
Do you think we could go on to the next page that I sent?
Yes, certainly can.
Okay. I think I have these problems enough to probably solve them on my own.
Okay. No, that's definitely, it helps if you direct. Because we certainly don't spend our time doing problems you know how to do.
Yeah.
Okay, you want to start here?
Yes, please.
What's the slope between those 2 points?
Okay. So,
remember the definition of slope. Always start there.
Okay.
What is slope equal to?
Slope is m equals rise over run.
That's the part to memorize. That's the part you want to know 10 years from now. 10 years from now, you're not going to know that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But 10 years from now, you should remember that slope is rise over run.
Okay.
Well, what's the rise? The rise is y sub 2 minus y sub 1, right? That's the change in the y's. The run is the change in the x's. And the only thing you have to do is make sure you go in the same direction with both. Well, what's y sub 2?
That would be 7.
That's y sub 2.
Okay, so it's 3.
However, you've brought up a good point that I can also go this way if I want, as long as I do it on top and bottom. And with this problem, it's a little easier to do that because we're left with all positives. In other words, I would rather do 7 minus 3 than 3 minus 7. So it's okay to do it this way.
Okay.
So it's what? Fill in everything for me.
So that would be negative 4.
Hold on.
Over.
Hold on. Let's do it one way or the other. You don't want to mix them up.
Okay.
First thing you did was you said 7 minus 3.
Yeah.
That's this way.
Okay.
That's y sub 1. That's y sub 2. That's x sub 1. That's x sub 2. So it's okay to do that way, but you got to do it with top and bottom. So what is y sub 1 minus y sub 2?
So that would be 7 minus 3.
Which is 4. Okay.
4.
Divided by
6 over. 6 minus 1 would be the x's, so that would be 5.
There's our slope.
Okay.
Now, had we chosen to do this way, we would have gotten 3 minus 7, which is negative 4. And we would have had 1 minus 6, which is negative 5. Well, negative 4 divided by negative 5 is 4/5, same slope as doing it this way. So you're going to get the same number. It's just one way can make the math a little easier. I would rather subtract these from these than the other way around.
Yeah.
And the only mistake you can make is to switch top and bottom. In other words, if I'm going to do this, I cannot do this. If I'm going to do y sub 1 minus y sub 2, I got to do x sub 1 minus x sub 2. I cannot do x sub 2 minus x sub 1 just because it's easier.
Okay.
So either one of these is good, but be consistent with top and bottom.
Okay.
Okay, midpoints are really easy.
Okay.
You don't care that we're looking at an x and y coordinate here. The only thing I care about is what's the midpoint of the x coordinates. What's halfway between 1 and 7?
Okay. So,
There's 1 on a number line. There's 7 on a number line. How do I find the halfway point? Same way you found the mid-segment. You add the two numbers and divide by 2. Just like we added the top base to the bottom base and divided by 2, that's the average base.
okay. So, to add those two, that would be 8.
Divide by 2.
4.
There's the midpoint between the x's. And is that the midpoint? In other words, it's 3 units between 1 and 4, and it's 3 units between 4 and 7. So that looks like the midpoint to me. But
Okay.
the way you get it is by adding the two coordinates and dividing by 2. So what's the midpoint of the y coordinates?
The y coordinates are 3 and negative 3. Wouldn't that be...
Look at the number line.
It'd be 0.
Correct. In other words, halfway between negative 3 and positive 3 has to be 0 because this distance has to be equal to this distance. Well, that's a distance of 3, that's a distance of 3.
Okay.
Now, could we get that answer by doing what I said to do in the first step? Add the two numbers, divide by 2.
You don't have to divide by 2. Right?
Well, but you got to use the right formula always. You don't have to divide by 2. I agree, because when 0's in the numerator, the answer is 0 whether you're dividing by 2 or 20. But
yeah.
the formula is you add the two numbers and divide by 2. You're still going to get 0. 0 divided by 2 is 0. So you get the right answer. But I want you to remember, because it won't always be easy. In other words, I'm going to give you a couple of points, and I want you to give me the midpoint.
Okay.
What's the midpoint of the x's? And always do them separately. In other words, the fact that we have an x and y coordinate doesn't changes nothing. We're still trying to find the midpoint between the x coordinates.
Okay, so that'd be negative 5 and 3. Add them together. So that's negative 2.
Now you got to divide by 2. Don't forget to divide by 2. Midpoint is splitting it in half.
That'd be negative 1.
Okay, so that's the midpoint for the x coordinate. How about the midpoint for the y coordinate?
7 plus negative 2, that's 5. 5 divided by 2, that's 2.5.
There you go. That's the way you find midpoint. So
okay.
Just always use that formula. And don't worry if the numbers are the same like this. You still get 0 divided by 2. Which is still 0. Okay. All right. To answer this question, we need to figure out the slopes of each of these lines they're talking about. So let's talk about AB. What is the slope of AB? We'll write it like that.
So would that again be rise over run?
Yep.
So equals y squared minus 1 and then minus 8. So that would be 2 and 4, so 2 minus 4. And then 1 and 3.
Mm-hmm.
So negative 2 over negative 2? Yeah, negative 2. So negative 2 over negative 2?
Which is?
0?
No. Any number divided by itself is 1.
Yeah.
So the slope is 1.
Okay.
Notice this would have been a little easier to do the math the other way. In
Mm-hmm.
other words, isn't it easier to do 4 minus 2 divided by 3 minus 1?
Yeah, that's
It gives you
easy.
2 over 2, which is also 1. We're always going to get the same answer. But when you're figuring slopes, if both calculations work better to do this minus this, then that's the direction I go.
Okay.
Most of the time it'll be about equal. In other words, one of them will give you a negative number no matter which way you go. But this line right here, it's so much easier if I do x or y sub 1 minus y sub 2 over x sub 1 minus x sub 2. But either way, we've got the slope of line AB. Now, the question wants us to compare it to DE, so what's the slope of DE?
So you could do 8 minus 3.
Okay,
And then,
this 8 and this 3?
yes.
Okay, so that's 5 in the numerator.
And then 3 minus 8, which is negative 5.
Okay, so what's this slope?
1 again?
Is that a number divided by itself?
No.
Okay, so it can't be 1. It's got to be negative.
Okay.
For one thing, when you take a positive divided by a negative, it stays negative.
Okay, so it'd be negative 1.
Negative 1. Okay?
Okay.
So, are those lines parallel?
Well, one's going through positive and the other one's going through a negative, so...
What determines parallel lines? Same slope. They have to have exactly the same slope to be parallel.
Okay, so...
Are these parallel?
No.
Okay. Now, the other thing is perpendicular. What determines perpendicularity?
I don't remember this one.
Slopes. Okay.
Okay.
You want the slope that's perpendicular, you flip and make it negative.
Okay.
Okay. Well, when I say flip, I mean if that's a ratio, let's say we had 3 over 2. Let's say I had a slope of 3 over 2.
Okay.
Well, the slope that's perpendicular to that is flip that and make it negative, or opposite this sign. So that would be negative 2/3. Okay? So if I had a line that had a slope of that and another line that had a slope of that, they would be perpendicular to one another.
Okay.
Well, is AB the negative reciprocal of DE?
Yes.
Yes, it is. Because 1 is the same as 1 over 1. And so when I flip 1, I still get 1. And then when I turn it negative, it's negative 1. So if you have a slope of 1 and another slope of negative 1, they are perpendicular to one another.
Okay. That makes
The other
sense.
line we have to compare it with is BC. So let's figure out the slope of BC.
So BC would be 2 minus 2 over...
So that gives you the numerator instantly.
Yeah.
What does that mean my slope's going to be? I don't care what the denominator is.
It would be 0 because anything multiplied by 0.
Anything divided into 0 is 0. So regardless of what the denominator is, my slope is 0. That's the flat line, horizontal line. In other words, if I draw a line like that, that has a slope of 0.
Okay.
That's what it means. And DE had a slope of -1.
So it's neither.
Exactly. It's not parallel. It's not perpendicular.
Okay.
AB we know, so we'd have to figure out CF and then do that same analysis. You want to go to a different problem?
Yeah, I think I can do that one on my own.
Good. This is this is really important. I'm going to say that only about a third of what you learn in geometry class do you have to retain for stuff beyond geometry. This is part of that third. Slopes,
Okay.
parallelness, perpendicularity. Remember those things, how they relate to one another.
Okay.
Okay? Two-column proofs, you won't ever have to know how to, you won't ever have to do those again. But
No.
this is different.
Good, because I'm not good at proofs.
Well, nobody is, but the beauty of that is you only have to do it for geometry class, not anything else. You want to go to this?
Yeah.
We got about 10 minutes left.
Okay.
Is this a regular hexagon? They want to know what x is, and that angle is 3x minus 27.
Okay.
So we need to figure out what that angle is.
Mm-hmm.
Once we know that angle, then I can just say 3x minus 27 equals that angle and solve for x.
Yeah.
So can we figure out that angle?
Yes.
What is it?
So, trying to remember how we did this in class.
What's
It was
the sum of the angles in that figure, in that hexagon?
Yeah.
That's where you start. Finding out what the sum of all of them are. Well, there's a formula for that. What is it?
Is it the n minus 2 times 180? Okay.
Does
So.
that work? Does that work for a triangle? How many sides in a triangle?
3.
What's the sum of the angles in a triangle?
180, so it doesn't really work for a triangle, but...
Hold it, it does work. 3 minus 2 is 1.
Okay.
Times 180 is 180.
Mm-hmm.
Does it work for a rectangle?
Yes.
If it works for a triangle and it works for a rectangle, that's probably the right formula. In other words, what I'm trying to tell you that if there's a formula and you can't remember exactly what it is, make sure it works on figures that you know the angles. You know that a triangle angles sum to 180. So you know the answer for a triangle, you know the answer for a quadrilateral. So if this formula works for both 3-sided figures and 4-sided figures, then it probably works for 6-sided figures. It's the right one. So what's the sum of my angles for this hexagon?
It'd be 720.
Okay. How many angles are there inside?
6.
Correct. So what's each angle equal to?
120?
Correct.
Oh.
What am I going to set equal to 120 to solve for x?
3x plus 27?
I think it's a minus, isn't it?
Oh, yeah, it's minus, sorry.
Okay. And then you know how to solve that, so we can go on.
Okay.
Which next one would you like to do? We're not going to be able to do all of these, but we can do 1, 2, or maybe 3 of them.
Let's go to 30.
Okay. What's that figure called?
Would that be a kite?
Yeah, kite has 2 adjacent sides that are equal, and these 2 sides are equal. They're not equal to each other, so it's not a rhombus, But a kite is where you have two sides equal like that, and these two sides are equal.
Okay.
What we know about a rhombus, what do we know about the angles of a rhombus?
Well, they all have to add up to 306.
Okay, that's true. It's a four-sided figure, so that's also true. But what else do I know about the angles? Look at it and tell me which angles are equal. 1, 2, 3, 4.
So 1 and 3 are equal to each other.
And only that. 2 and 4,
Yeah.
2 and 4 are not equal. You can see that from the picture. 110 is not equal to 60. But this angle here is equal to that angle there. So now, what equation can I write that only is going to have one variable in it, and it's going to allow me to solve for x?
So,
how many angles do we have here?
you have 4.
Do we know them all?
We know 2 of them.
I know all 4 of them. That one's 60. What's this one? Same as this one. What's this one?
15x
x minus 35. That's all we need to know. Because notice now when I write 60 plus 15x minus 35 plus 110 plus another 15x minus 35 for that opposite angle, all of that has to add to 360. Again, we've got an equation with only one variable.
Okay.
And the rest is simple. You know how to solve for x there.
Yeah.
Okay. All of these are all about setting up the equation. And in fact, that's what geometry in general tends to be. It's as much algebra as geometry in terms of getting the answers. But setting up the equations is where you need to know the geometry.
Yeah.
In 31, what's that called again?
For 31?
What's that line right there called?
The mid-segment.
Mid-segment. Mid-segment. And it can be with triangles or trapezoids. You can have them.
Okay.
And they do the same thing. They bisect the two sides that they join. In other words, it doesn't matter if I have a trapezoid with a mid-segment. It bisects that side and it bisects that side. That makes it parallel to top and bottom if it's a trapezoid. In a triangle, it just makes it parallel to the bottom. In other words, when I have a mid-segment, it bisects that side and bisects that side, it's parallel to this bottom line. Now, once I've determined that that's parallel to that, what am I looking at here?
So,
what must it be given the subject matter that you're dealing with right now in geometry? Is it congruent triangles?
Yes.
No. Congruent triangles are equal triangles.
Yeah.
And that's not what you're dealing with anyway.
Okay.
Right now you're dealing with similar triangles, right?
Mm-hmm.
So if I'm looking for a relationship here, it's probably similarity is what I'm going to find, right?
Okay.
Well, this little triangle here is similar to the big triangle. This is actually the same problem we did earlier. Exactly the same. Just different numbers. What's this measurement right here?
20 centimeters?
No. What's this measurement here?
22 centimeters.
Okay, what's the double hash mark mean?
That it's double that number.
The same.
Okay.
means it's congruent. So that's
Okay.
22. Okay? That's a single hash mark. So there's no way that is equal to this side. That is equal to this. Okay? So if I want to label this picture, this time I'm not going to separate it out. Maybe it doesn't help. I'm just going to label everything I know. That's 22. That's 22. That's 20. What is it from A to B?
So wouldn't that also be 20? Because it's...
Okay. What's my similarity ratio between the big triangle and the little triangle?
Would it be...
Okay, let's separate them out. Here's my big triangle.
Okay.
Here's my little triangle. That's 20. What's this side?
20.
What's that side?
Oh, 40.
What's my similarity ratio?
2.
2 to 1.
Okay.
Okay, so similarity ratio is 2 to 1. That means every single corresponding side of this big triangle has to be twice its corresponding side of this triangle.
Okay.
And they want the perimeter. Oh no, they give you the perimeter of DBE, the big triangle. What's this side here?
44.
And this side is 6x minus 10. So what is this side over here?
Would you have to double that too?
Every side is twice the other side.
So would it be 12x minus 20?
Correct.
Okay.
Now we have all three sides. Even though one of them is in terms of x, that's okay, because we know what the perimeter is. It's 100.
Yeah.
So what equation can I write now?
So
The perimeter of that triangle is 100.
Okay, so would it be 12x minus 20 equals...
Hold on. The perimeter, add all three sides up. One second, Kendall. Audrey? Hi. I just am finishing up a session. I will be with you. I will call you back on this number. I'll call you back in 2 minutes or 1 minute. All right. Bye-bye. So what's my equation? 12x minus 20 what?
Would it be plus 40 and then plus 44 equals 100?
That's it.
Okay.
Now you just have to solve for x.
Okay. Seems simple enough.
All right. Kendall, let's see, we have another session scheduled, I believe.
For tomorrow and Wednesday.
Okay, cool. We'll pick up on these same problems. We will have time to cover them all, I guess, huh?
Yeah.
Okay.
Thank you.
You're welcome. Talk to you tomorrow.
Mm-hmm.